So today we're going to be dividing polynomials, where this time, instead of dealing with simple linear coefficients where the x has a 1 coefficient, I'm going to have a coefficient of 2 or more or something else in front of the x. And we're going to see that with dividing polynomials, this is going to be the limit of really what we're going to be doing. Outside of that, mostly we break it down into the factors so that we could use synthetic division, which we will learn in a future video. But let's take a look and see how we do this. So we're going to set this process up the exact same as we always have. So I'm going to put the bottom, or my denominator, on the outside of a division setup, I guess you would say. Negative 12x cubed plus 4x squared plus 3x minus 1. And again, what we're going to do is we're going to consider the first and only the first values. And I know in one of the previous videos I said 2 times what gives me negative 12, but I think an easier way to explain this is that we're going to take that negative 12x cubed and we're going to divide it by 2x, and that will give us the 2x times what gives me negative 12x cubed. So 12, or negative 12 divided by 2 is negative 6x squared, because one of those x's cancel it out, and that is actually what we're going to put up at the top. So negative 6x squared. And the process that we're going to do here is we are going to multiply both terms, or all terms inside of our denominator, by our answer right there. So negative 6 times gives me a negative 12x cubed, which again, we want this to be identical, and we don't really care what happens to the second one. That's going to give us a 6x squared. Again, like I said, we're not really too concerned with that. When we subtract it, we're going to change the signs, which is going to cancel that out, and it's going to leave us with a negative 2x squared. Drag down our next term, and we repeat the process. I'm only going to look at the first terms, so negative 2x squared divided by 2x gives us what? Oh, that's a negative 1x. So I'm just going to put negative x. I'm going to multiply it. So negative x times 2x, negative 2x squared. Again, those are the same thing. That's what we want. We don't really care what happens to the other part. I'm going to go ahead, change the signs. Cancels out. We're left with a 2x minus 1. Again, we always hope for the fact that I'm going to get the same thing right here, because that means that this is a factor of that. But I'm going to do it for the last time. So 2x over 2x is equal to 1. Perfect. I don't know why I boxed it up that time. It just felt appropriate. Regardless, you don't need to box up your answer right there. 1 times 2 is 2x minus 1. Actually, I may have misspoken. This does not need to be that. It just happened to be because I was 1. Really what you're wanting to do is when you multiply or when you distribute this 1 times both terms, you want these two to match. If they match, that means it's a root. If they don't, that means it's not a root. So the last combination that we do here, if they match, you found your root. If not, you just got to keep looking. So I have a 0 remainder, which means that my answer, and my final answer, is this up here. So we see that nothing actually changes if I believe the divisor, the denominator, has a coefficient in front of it. What may change is, okay, so this is an edit to the question, because when I created this question originally, I wrote 4x to the power 4 instead of 48x to the power 4, and I got a big remainder left over, and that's not going to be the case. So let's go over this. Whenever I have a numerator like this, I notice that I'm missing a term right here. I go from x to the 4th, to the 3rd, to the 2nd. I don't have a single x term. So I'm going to need that as part of my problem setup, where I have 2x plus 5. I'm going to put in what I call a 0 coefficient. And so that means I'm going to include my 48x4, I'm going to include my 28x3, my 270x squared, and I'm going to include in a 0x. I need to include this because when I start distributing, I'm going to have an x and 1x beneath that every single time. So I'll get a 4 and a 3 and a 2 and a 1. And without that 0 coefficient, I would have a 2 and a nothing that I'm trying to combine, and I'll miss out on this term and it won't combine from this point forward. So in order to avoid that, we plug in a 0 coefficient. And so let's check to see how this all works out. So I'm going to get 48x4 divided by 2x, which is going to leave me with a 24x cubed. So 24x cubed is going to be my first value right there. I'm going to distribute 48x. The pen's dying on me. 48x4. So 5 by 24, that's going to give us, let's see, 120. We're going to change our signs and reduce. So 28 minus 120, let's see, that's going to be negative 100. That's going to be negative 92. So far, this doesn't look any different than what we've been doing because we're not quite here yet. Once we try and drag this down, we'll see where the terms won't combine. So far, it's still pretty much the same. 92x cubed, 2x. Let's see, 92, that's going to be 45, 46. Drag that over there, which is going to give us a negative 92x cubed. 46 times 5, let's see, that's going to give us negative 230. So when we combine these, let's change the signs, cancel that out. It's going to be a negative 40x squared. Now, here's the important part. When I drag down that 0 coefficient, that allows me to, when I distribute, I'll have a single x right here. X times x is going to be x squared. Those will match up. The x times the 5 will be a single x, and those will match up. And we need to be able to do that. That's an incredibly important part of what we're doing. So let's see, negative 40x squared over 2x. That's going to be a negative 20x. Perfect. I'm going to change my signs. Cancels out. Boom, I can combine these. I'll have a 100x plus 250, and the pattern continues. If, as you can see, I was right at this part and I didn't include that 0 coefficient, I would have, let's do this in black, a negative 40x squared plus 250. Remember, I'm assuming that I didn't plug that, so I would have my negative 40x, and I would have dragged down my 250. I would have still gotten my negative 20x, but when I distributed, I would have gotten negative 40x minus 100x. And when I went to combine, I would have said, okay, cool, cancel out. Okay, I have a 100x plus 250. So it would have skipped, and in this case, that wouldn't have been too terrible of an issue because I would have just ended up with my next line. But again, if there's more than one 0, sometimes that's going to kind of push the problem on. And so we always like to put a 0 coefficient in there to keep the pattern nice and neat, and so that you don't accidentally turn that into because what students often like to do is turn this into a 350x, which we know is wrong because those aren't like terms, but that tends to be the pattern that we go into. We want to avoid that. Cool. And so as we continue on, let's see, 100x divided by 2x, that's going to be 50. And perfect. These things go right along, cancel, cancel. I have a 0 remainder, which means that my answer is, in fact, that right there. Off into the next one. Let's hope this one works a little bit better. this is a much smaller problem. I'm going to take my 2x plus 2 and divide it into the negative 6x cubed plus 26x squared. Oh, I'm missing my x term. So 0x minus 32. Perfect. So let's see how well I type this one. 6x cubed over 2x, negative 3x squared. Let's multiply that out. Plus, plus, cancels. That gives me a 32x squared plus a 0x. And we're going to do it again. So 32x squared over 2x, which is going to be a 16x. So 32x squared plus a 32x. We're going to change our signs. Ooh, this does look like it works out. So minus 32x minus 32. Yes. It's going to be the same setup. So that when we change our signs, there we go, we have a 0 remainder. So this is our answer. That's kind of what I wanted the last question to go like, but we're going to take it. We understand that we must have a 0 coefficient. And the last question that you may have is going to be, well, what happens if I have something bigger than a linear factor? We've noticed that previously I only have a single x with 2 terms. What happens if I have 3? Well, the setup isn't going to be any different. We're going to set it up just like what we've been doing. We're going to take what's on the outside or on the bottom and put it on the outside. What's on the inside is going to be popped right here. And take care that anytime we're missing a term, so if I'm missing an x cubed, we add a 0x. Or 0x cubed, I should say. I'm also missing an x, so I'm going to add another 0 coefficient. This one has 2. Then the process works the same. So at this point, what I want you to try is I want you to try and work through this. See how the question works. Unpause it when you're done and see how the work went. Hopefully this time we can trust the fact that I did create these problems correctly. It does seem like I may have an error in the code of anything of a 4th degree higher. So let's see how we do. Divide out my first 2 terms, 36x4 over 6x2, 6x2. Multiply them out. So it's going to be 18 and 60, 78x cubed. Boom. I got to change 3 signs. Cancels. It's not plus. Negative 36 and negative 97, that's going to make that a negative 103, a negative 133. These numbers are already getting a little large, so I'm a little hesitant as to how I typed this in. Let's see, 60 is 10 times, and that looks like 3 more times, so 13x. Cool. By 13 is negative 169. 13 times 6. It's going to be 60 and 18. Perfect. So we're going to subtract this, add this, subtract this. Cancels out. Let's see, that's going to be 33x squared minus 78x plus 36. sorry, that's 36x squared. Which is 6. And that worked out perfectly. Minus, plus, minus. All three of them cancel out. I have no remainder, which means my answer is evenly this, and that is a factor of the thing above it. And there we go.